Okay, we're in section 35, and this is, again, a system of linear equations. We certainly have techniques that we'd like you to try. And the first technique we'd like to do is a visual approach, which is drawing the two lines, finding out where those two lines intersect. All right, that's one way we'd like you to do it. And certainly we provide really good pictures for you. And we certainly discuss this in lecture. We're hoping if you have good pictures over here, that's relatively simple to find a point of intersection. However, I want to point out that this can be a very deceptive method, and that's why we really need to, whatever we say is the answer, we need to check it. All right, and we'll go through that. All right, and it's just to overview what we did in lecture. The other thing is substitution, which is perhaps a little bit easier. It's algebraic, it's not visual, but we're still going to check it. We're going to check it. Now we're going to go to the examples. As we go through the examples, certainly I'll read them to you. I want to follow the instructions that we're reading to you. All right, give me 1 second. I got to do a new share here, don't I? Okay, so this is number one, all right? And certainly as we go through these problems over here, my encouragement to you is to read it and understand what you've read, all right? So I'm going to pull number one on the side. And I'm going to kind of push this over. Whoops, jumpy screen today. So I'm just going to, talk about it. And what they're saying is determine if this ordered pair. Well, you have to know that ordered pairs are given to you in a proper order, and that order would be X, comma, Y. So what are they saying over here? This ordered pair, and I'll just outline that for you if you can't understand what I'm talking about over here. This is the ordered pair they're talking about. So what do I know? I know X is 1, and I know Y is 1. The question is it true? I don't know. Is the solution? I have no idea. So I got to check it. Where do you check it? Here. I'm going to put this down for you. Well, if X is 1, you get 2 and 1. And if Y is 1, you get -5 and a 5. Well, 2 minus 5 is -3. Checked beautifully. 1 plus 5, however, is 6. It is not equal to 8, as they said it should be. So the answer here is no, this is not a solution. All right, we're doing okay. We did the work. Let's go to number 2. Now, number 2 says solve by graphing. All right, this, for some students, is incredibly difficult to do. I want to encourage you, though, to use graph paper. I'm going to pull this over here. I'm going to blow this thing up. And what I'm going to do is I'm going to try to use graph paper to do the problem. All right. Now, what I want to claim over here is one line at a time. I want to do this line over here. And that line is X plus Y is equal to -3. Now, I got to be honest, if I were doing this problem over here, I would probably use the numbers that I like, and I like finger numbers. So for example, I would make a little table up. X is 0. What would Y be? -3. That's simple. I'd set Y to be 0. I'd get -3. I'm going to plot those 2 points for you. All right. And, 0 -3 and -3 over here. Now, by the way, I'm not a great artist, but I'm going to try to draw a line through that. And I'm not saying I'm doing a great job. All right, that line's done. Now I'm going to do the other line. All right, I'll do a different color. And that's X minus Y is equal to 5. And again, one of the reasons I don't like graphing, I'm not very good at graphing. So I'm going to set X to be 0. And what would you get for Y? -5. I'm going to set Y to be 0, and you would get 5 for X. All right, let me plot that down for you. Kind of nasty looking, but I'll do it. 0 -5. And yeah, you have to be able to plot points, right? And then 5, 0. Now, my claim over here, I certainly know they intersected, but I'm not absolutely sure about that. I'm not sure, when I say not sure about what the point is. But I'm looking at this thing over here, and I'm going to simply say, I'm going to trust it. I'm going to say, it looks like the x is 1, and it looks like the y is -4. This looks like what's called a point of intersection. I don't know if it's true, though. I got to check it out. I got to check that. And if it checks, I'm going to write that down for an answer. So let's check it. Where do I check it? Here. Well, if I think x is 1, I get 1 and 1. And if I think y is -4, I would get -4 plus 4. I'm just looking at the original system. What do you get here? -3. What do you get there? It's 5. It checks beautifully. So I now know my answer is 1 minus 4. This is an ordered pair. It's a point. You can also write down x equals 1, y equals -4. There's nothing wrong with writing that answer down either. Now let's look at the answer key, see how we did. This number 2, I'm hoping to see 1 minus 4 in the answer key. And what do we see? Lo and behold, we see it. All right, I'm going to do number 3 now. It says solve by graphing. I'm going to pull it on the side, just this business over here. And I'll put this up here. And I'm going to blow this graph paper up, make it nice and big and easy for me to count on. Let me get rid of this graph paper over here. I'll use that one piece later, okay? So what I'm going to do over here, I got to graph these lines. And again, if you haven't practiced the line graphing, it's going to seem difficult. But the first equation is really simple. And what is it? X, whoops, I'm sorry about that. I'm going to use green. X equals -4. I'm going to put my table down, 2 points. There's a line. And x is -4. Well, y can be any number in the universe. I'll put 0 down. Put another number down, like -4, 1. I'm going to plot that down for you. And, -4, 0. And -4, 1. What kind of line is that? Well, as expected, that's a vertical line. Very easy to draw. Again, if you find that difficult, it probably shouldn't be in this section. Let's do the next line. I'll put in blue. And that would be y equals 3. All right, what does that mean? Little table of values go down, x and y. So I would say x is whatever I want it to be because it has nothing to do with x, but the y is always 3. Let's plot those points down. So let's see, 3, and then 1, 3. And then I'll put my little line through there. And what kind of line is that? Horizontal line. Now, looking at the picture, I hope you realize there's a point of intersection. Point of intersection. And this could get tough. Let's take a look at it. What do I believe x is? Looking at my picture, I believe my x is -4 looking at my picture, and I believe the y is 3. All right, you should check it in the original system. What's the original system? This over here. Let's see if that's true. What would you get over there? I'm doing the check. Let's see if x is -4, I get -4 plus 5 is 1. That checks. And if y is 3, 3 minus 1 is 2, and that also checks. So I got my point of intersection, and that point is -4, 3. You can write down as a point of intersection, or you can put down the xy. What's x? -4. What's y? Y is 3. Let me go back to the answer key, and I'm hoping to see that. I'm hoping to see -4, 3. And what do I see? That over here. All right. Now let's do number 4. I'm going to pull this piece of graph paper over. And I want to do problem number 4 now. Now, granted, you don't need to use the graph paper we provide to you, but if you do want to use it, you're more than welcome to use that. It's embedded in my notes, by the way. Let's pull this on the side. And I'll push this over here a little bit. And I'm going to push this around, push this up here, make it a little bit bigger. I got to make this a lot bigger because my graphs really depend on a good picture. And I'll do one line at a time. And I'm going to do the first line, which is x. You know what? I don't want to use red. I'm going to use blue. X minus 2y is equal to 1. I like to use tables. Again, the point here is you've got to get 2 easy points. So I'm going to set y to be 0, and you get 1 for x. That was pretty simple. Now I'm going to set y to be 1. And what would you get for x? You get 3. All right. Let's see if that's true though. So if X is 1, you get 1. And if Y is 0, you get, well, that's pretty good. That checks out. Let's see, 3 minus, yeah, they both check out. I'm going to plot that now. So be very careful, by the way. So right here, that's the 1, 0, and the other one's 3, 1. I'm not very good at drawing lines, by the way, but that's my best attempt at drawing that line. All right, I'm going to do the other line. And the other line I'm putting green. I'll put 2y minus x equals 1. And I'm going to put a little table down. And I'm going to set y to be 0. And x would be minus 1. I'll set y to be 1. And x would be 1. All right, let's see if that works out. Well, that would give you 2 minus 1. That's 1. And if x is minus 1, that works good. Let's put this down now. Let's say 1, 1. And the other one is minus 1, 0 over here somewhere. All right. Let's draw a line through that. I'm not going too fast with that, right? And yeah, look at that. I don't really think that graph is the best graph in the world, but I'm looking at that. I don't think those lines would ever intersect. So I would simply say there's no point of intersection. All right, let's go back. Well, look at the answer key. No, I messed it up though, didn't I? Whoops, didn't mean to do that. Look at that. No solution. These lines never intersect. And I wrote that down the key, right? Not the key, but I wrote that down as my answer. So I'm feeling pretty good about that. All right, let's go to number 5. A little more difficult. Let's see if I have any more graph paper liner. Yeah, I do, right over here. Let me pull this around over here. Like this. Pull this thing up here. Pull it over here. Start blowing this thing up. And I'll do this over here. All right, let's take a look at it. And one line at a time, right? Now the first line I want to put down is 2x minus 4y is equal to 0. Well, again, as a little table goes down, right? X and y, 0, 0. That worked beautifully. Let's try another one. All right, because 0 minus 0 is still 0. Let me try x to be, I don't know, 2. Well, 2 times 2 is 4. So y would have to be 1 then, right? Because 2 times 2 is 4, and 4 times 1 is 4, and 4 minus 4 is 0. So I'm going to plot that. I blow that up a little bit. I got the 0, 0, and the 2, 1 goes down, right? And again, I really mean this. I'm never really great at drawing lines. And to me, that looks like a line, but to other people, they say it's kind of crooked to them. It's my best attempt at the line. Let's do the other one. And I'll write this one down for you. It's y equals x plus 1. Now I'll make a little table up, x and y. I'll set x to be 0. And what would y be? Y would be 1. I will set x to be minus 1, and the y would be 0. Let me plot those 2 points, 0, 1. Put that over here. And what was the other point? Minus 1, 0. It's going to be a tough one, isn't it? A really tough one. Yeah, looking at that, I know they intersect. The slopes are different. I'm kind of wondering, Maybe I didn't do a very good job. I got to blow it up, I really do. I got to get rid of my line there. Kind of trace that over, see if I can do it. Maybe here. I don't know, maybe not. Right? What's that point? I don't know if it's going to work, right? So I think the point of intersection, this is what makes graphing so difficult for students. I wonder if their lines look good or not. But I'm looking at, it looks like -2, right? Comma, -1. Well, I got to see if, if that's true. And, I'm thinking -2, -1. Well, I'm going to check it. And what would you get? We're checking it here. Well, that would give you -4. Let's see, +4 equals 0. It checked there. The second line would be y is -1 equals -2 plus 1, and that also checks. So what's the point of intersection? That's the point of intersection. Let's write that down. We'll check with the key later. You could also write down x equals -2 and y equals -1. I want to point out, even with graph paper, this technique is difficult for students. It's difficult for me too. And the reason for that, I'm not a very good, I don't really draw great pictures. I got an idea that they're going to be pretty simple though. Let's look at the answer key, and we're seeing that in the answer key. All right, let's go to the next question, number 5, and this is the next page. No, I'm sorry, number 6. And number 6, we're out of the graphing mode. We're into the substitution mode. I like substitution, no picture necessary. So what am I going to do over here? Boy, it looks like the same question, doesn't it? It is. Well, if you're going to use substitution, what you need to do is take one of those two equations and solve for a letter. What I noticed immediately, the second equation is already solved for y. And what's y equal to? X plus 1. What we're going to do with this is we're going to take this thing here and we're going to substitute into the first equation. Let's write that down. 2x minus 4, and y says it's x plus 1, right? Equals 0. 2x minus 4x minus 4 equals 0. Minus 2x minus 4 equals 0. Minus 2x equals 4, or x equals -2. How do you get the y? Plug it in here. Let's do that. And what's y going to be equal to? Y will be x, which is -2 plus 1. So y will equal -1. So I got my ordered pair. My ordered pair is going to be -2, comma -1. Or you could write down x is -2 and y is -1. It's a fine answer. That's a fine answer. If you look at your answer key, we just did that graphically. We're really getting the same answer. You can also check it again if you want. Let's do number 7. Really same story. What are you doing? Substitution method. Well, immediately what I notice is over here is that this second equation is already solved for y. It says what y is. What I'm going to do is take this and plug it in up here. And let's see what happens. 6x plus 8y, and y is going to be 3x minus 4 is equal to -12. I'm just plugging it in. What do you get? 6x plus 24x minus 32 equals -12. 30x minus 32 equals -12. I know it's tough. 30x, I'm going to add 32 to both sides, and you would get 20. All right, now what I'm going to do? Divide both sides by 30. I think it's look pretty nasty, right? X equals 2/3. Someone says, I don't like a fraction. I don't think you should give me fractions. Fractions are going to pop up on occasion, right? So my understanding, if X is 2/3, how would I get Y? Well, I'm going to say plug it in here. And what would you get? You would get Y equals 3 times 2/3 minus 4. What's nice? The 3's cancel off. And what do you get? 2 minus 4, which is -2. So Y is -2. So I can put a box in that. I'm also going to write it as an ordered pair. The ordered pair is X, which is 2/3. What's the Y? -2. All right. Yeah, you could check it. I'm going to check it with the key though. 2/3 minus 2. X is 2/3. Y is -2. All right. I'm going to go to number 8. And number 8 says motorboat problem. All right. Now, granted, I'm gonna give myself a little bit more room to do it, and I'm gonna pull it on the side. Yeah, it's a little dirty here, but whoops, sorry about that. Let me just back up a little bit. And let me just push this around a little bit, and I'm gonna pull this away. And yeah, I know it's a little bit dirty. I'm gonna erase that stuff there for you. All right, let's take a look. So a motorboat traveling with the current went 15 miles in 1 hour. So I'm going to put this down for you. So with current, it went 15 miles in 1 hour, which is a rate, which is 15 miles per hour. It's a motorboat, by the way, against the current. It took 3 hours to travel the same distance. I'll put that down. So it's 15 miles in 3 hours. That's against the current, by the way, which turns out to be 5 miles per hour. That's its average rate against and average rate with the current. Now, I think I want to say is, find the rate of the boat in calm water. So I don't know what that is, but I'll put this down for you. X is the rate of boat in calm water. And the rate of the current. I'll say Y is the rate of the current. Right. Simplistically, we're going to say with the current, it's going to be the rate of the boat in calm water plus the current rate would be the rate with the current. And what's that rate? 15 miles per hour. If you're going against the current, it's going to be the rate of the boat in calm water, subtract the rate of the current. It's working against that. How fast is that? 5. What's nice about this system? It's lining up beautifully. What do you get? 2x, the y's disappear, and you get 20. Divide both sides by 2, and you get something pretty simple. You get x equals 10. I would recommend looking at this equation over here and coming up with the y. Well, if x is 10, y would have to be 5. So I'm going to say the rate of the boat in calm water is 10 miles per hour, and the rate of the current is 5 miles per hour. Let's go back and look at the K and see if we've done it. See if we got the right answer. The rate of the boat in calm water is 10 miles per hour, and the rate of the current is 5 miles per hour. Okay, thank you for listening. Again, don't forget to do the homework, though. You have to really practice this material. It isn't like, oh, Jay, thank God that's over. No, you need to practice. All right. And give me a second here.